Well, dear student, in last video I derived linear width of the slits of dark and bright fringes. They were same. Now I come to the next topic here, angular position. The same diagram you use here. I have discussed S1, S2 are identified single source of light of wavelength lambda. Point P may lie on nth dark fringe or any bright fringe. At O we get central fringe. If in this diagram, if in figure, point P lies on nth bright fringe, then its angular position, angular position theta n, it may be marked as theta n, and its distance from central maximum equal to xn. In place of theta we can use here theta, in place of x we can use xn. Now theta here is small angle. Why? Because since capital D very much greater than D, I have told you that D is meter order, small d millimeter or fraction of millimeter. So theta n is the small angle, and hence theta n equal to tan theta n equal to xn upon d. What is xn? Distance of nth bright fringe. But in last video we have proved, but we know that xn is equal to n lambda upon small d. So theta n equal to 1 upon d into, so theta n comes out to be n lambda by d. So angular position depends only on distance small d and wavelength used and its number. If it is 10 fringe, so you put here 10 lambda d upon d. It is independent of capital D. Many times question has been asked in board exam, how would the angular position change if distance capital D is doubled? So it is independent of this and has no change. It is what? Angular position of nth bright fringe. If point P lies on mth dark fringe, then theta equal to theta n or x equal to xn. So theta m is equal to tan theta m equal to xn upon. Basically, I forgot to tell you here, when we use theta m directly, एक्सएम इन मीटर, डी इन मीटर या सेंटीमीटर सेंटीमीटर, then angle comes in radian. And I have told you many times that pi radian is equal to 1 degree, and hence 1 degree is equal to pi upon 180, 3.14 upon 180 radian. So when you will use meter or this in meter, please remember that this will be in degree. Oh, sorry, radian. If you are given the angle theta in degree, you have to change in radian. So be careful. Now we know xm. We know xm equal to 2m minus 1 into lambda d upon 2d tha. So what is theta m? So theta m is equal to 1 upon d into 2m minus 1 into lambda d upon 2d. Don't forget, here comes 2. Or theta m 2m minus 1 into lambda upon 2d. Again, this also independent of capital D. So these equation 1 and 2 tell you the angular position. Actually, this derivation is not mentioned in any book. In NCERT book, this is also known, but question is there. I will tell you. Now, what is angular width? Angular width. Angular width of bright fringe. So theta n, that delta theta will be theta n plus 1 minus theta n. It will be the width of dark, angular dark, dark fringe. Because between two consecutive bright there is dark. So theta n was, so it will be n plus 1 lambda upon d or minus n lambda upon d. So when you subtract lambda upon d common, n plus 1 minus n, so it is lambda by d. So angular position will be independent of capital D again, and number of fringe also. Delta theta, sorry. This is the angular width of dark fringe. For bright fringe, ये bright क्यों निकाल देना, कोई बात नहीं, बराबर लिखो. यहाँ you can write here dark. अब आइए bright fringe पर. Bright fringe. और delta theta will be xm plus 1 minus xm. You please make correction there. That was angular width of dark fringe, bright. Between two dark there is, sorry, I will क्या लिख दिया, theta m plus 1 minus theta m. When things are simple ना, तो we do mistakes there. तो theta m plus 1 यहाँ पे लिखेंगे m की जगह m plus 1, यहाँ पर m plus 1, तो we get 2m plus 1 into lambda by 2d or minus 2m minus 1 lambda by 2d. Again here lambda by 2d common, 2m plus 1 minus 2m plus 1 minus 2m plus 1. It again comes lambda by d. These two get cancelled, 2, 1 plus 1, 2 cancel. So the angular width will also be same. And the same way, if the whole apparatus lived in liquid, so wavelength of light changes. So you use lambda dash. So you can solve that yourself. Actually, so this was all about derivation of fringe, position of bright fringe, dark fringe, angular position, etc. I have told everything. But now, here there is very important point. How to obtain interference pattern, or some people say condition of sustained interference. Condition of sustained interference. Sustained means if there is bright, it always remain bright. If this is dark, point P dark, it should remain dark. Means any point, the nature of fringe should not change. Means wherever there is bright fringe, it should remain bright. Wherever it is dark fringe, it should remain dark till it is illuminated by the source S. So two main conditions, mathematical conditions are there, and others are this practical conditions. Theoretically or technically, I should say, condition number 1. Two sources should be monochromatic sources of light. If they are these S1 S2, we have taken two अलग-अलग color और white. If this is white source, तो क्या होगा? Source S1 S2 will have different wavelength, and according to relation delta phi equal to 2 pi upon lambda into delta x. For same value of delta x, means at any point P, different colors, or different wavelength will meet in different phases, and hence there will be general illumination of light, by some color giving maximum, some minimum, some in between. So dark and bright fringe will not be obtained. This is first condition. Number 2 condition, two sources of light should be coherent. I have told in last video the meaning of coherent and monochromatic sources. It means two sources should emit in same phase or with a constant phase difference. If there is some difference, say of 10 degree, 15 degree, 1 degree, so that should not change also. Otherwise, if phase keep on changing, then intensity of light at every point will keep on changing, and hence dark bright fringe will not be obtained. Number 3. अब ये तो कंडीशन होगी. अभी तीसरी लास्ट दिस कंडीशन आर प्रैक्टिकल प्रॉब्लम्स. Condition for practical difficulties. To obtain wider fringes, capital D should be as large, should be large as possible. Actually, if capital D become very large, so intensity of fringes will decrease. क्यों? I have told that अगर ये पॉइंट सोर्स है यहाँ पर और यहाँ पॉइंट पी आर डिस्टेंस, तो I equal to P upon 4 pi r square. A small amount of energy will fall in this large area, and that way intensity will decrease. तो इसलिए लिखा as large as possible, and small d should be very small. If you make it 0 ना, by W is equal to lambda d upon small d है, तो you may think कि d width will be infinite, फिर तो फ्रिंज बनेगी ना, फिर दोनों सोर्स एक हो गए. Light should come from two sources to produce interference. The fact is this. तो distance होना चाहिए, but should be small. Next, number 4. To obtain a good contrast between maximum to obtain good contrast between bright and, in simple language, bright and dark fringes. The amplitude of light waves from two slits should be the same. How the amplitude will be same? How can you making equal width of slit? By intensely proportional to square of amplitude. Or intensity means amount of energy coming out. So how much energy will come out depend upon width also. So if they have equal width, then we are getting here wave of same frequency. Why it is so? It is because now I have told you I maximum upon I minimum equal to A1 plus A2 whole square upon A1 minus A2 whole square. A1, A2 are the amplitude. If A1 is equal to A2, so dark becomes 0 and there will be a good contrast with 0 and maximum. contrast difference between the intensity should be large. Now, number 5. Number 5, which is very important. 6 है, practical problem है ये. Again, for good contrast, between bright and dark, fringes, the two slits should be very narrow. It is because if the fringes are very wide source supposed to be consist of so many pairs of point sources. अगर ये wide source है तो यहाँ suppose many point sources and pair of point sources produce their own fringes. You can read it from the book. Because it is going lengthy. And the fringes of these pairs will be little shifted from the principal fringes obtained, and that overlapping will decrease the intensity of fringes. So it should be very narrow. If the width is less than the fringe width, then you get good contrast. If this become more, fringes disappear. Now last condition here, 6th condition. The source slit, size of the source slit, make certain angle theta here. The angle subtended by source slit S on the two slits should be smaller than angular width of fringes. If this angle is theta, this distance, suppose I say the width is small s and this is capital S, then small s upon s will be the angle subtended by this here. It should be less than lambda by t. If this angle is more than this, fringes will disappear. So this is also very important. The question is asked, if we increase the width of source slit, what will happen? So fringes will eliminate. Or if we move the source towards this, again angle will increase. So gradually the intensity of fringes will decrease and finally disappear. So this is something about the condition. In next video I will take 2 more problems of this experiment, यानी कि interference with white source. अगर ये source as white source हो तो क्या होगा? And if in the path of one light, if we place some transparent material like glass in the path of light going from one slit, how the slit will change? Thank you.